All right, last try. Here we go. I'm giving up. Find each value of theta, right? So that theta is between 0 and 2 pi, right? So now we have radians. So in the last three up top, we had degrees. So on these, we are looking for radians. And one thing to keep in mind is, I know I talked about this in class a little bit, um, right? So it's kind of easy to remember those important numbers. So we had a 180, we had a 90 degree, 270, and then 0 or 360. So now we're changing it, right? So we're talking about radians. So this is pi. The one up top is pi over 2. The one downstairs is 3 pi over 2. And then the last one is 2 pi or just 0. And when we're getting all of these decimals, it's kind of hard to think about, all right, where are these quadrants? When I get a decimal, what quadrant does it go in? And kind of think about pi is 3.14. Right, give or take, right? It's a little bit more, whatever. I'm rounding. So if you chop that in half, that's going to be about 1 point. I don't know what that is. 3.14 divided by 2. All right, that's 1.57. So 1.57. And then the other one, I'm going to multiply it by 3. It's going to give us 4.71. And then this one, 6.28, give or take. All right. So when we're getting decimals, if you get a value that's like 1.7, all right, 1.7 is going to be somewhere up here because, pi over 2 is 1.57. If you get something that is, 4.1, that's going to be down here is between 3.14 and 4.71. So those are, I guess, kind of, I don't want to say important numbers, but those are those kind of specific values that break up the quadrants. And that's just something to consider when we are doing these types of problems, right? So on the first one here, when we switch it over, just again, make sure you're in radians this time because we are working with radians. You want to do the inverse sign now. The inverse sign of 0.82259. All right, and that gives you a decimal at 0.965. So if we just want to think about it, 0.965 is somewhere in the first quadrant because that's between 0 and 1.59. All right, so again, I forgot that number already. I'm just going to round it. What do they want? They want 2 decimals, so that's what I'm going to do. All right, so 0.9, we're going to call it 0.97. So this angle right here is 0.97. All right, radians, not degrees, radians. Keep in mind, this is, again, this is a positive number. Right, we know sine is positive in quadrant 1 and quadrant 2. So the second value we need is going to be this one. Right? And how can we get that value? Well, we know that 0.97, that is our reference angle, 0.97. So to figure these out on the previous problems, we did 180 minus, that reference angle. Now we want to do pi minus that reference angle. Right? So I'm just going to do 3.14. Right, they're telling us to round to 2 decimals, so that's what I'm going to do. 3.14 minus 0.97, and that's going to give us that second angle. I should have been doing this in purple, but whatever that is, I don't know what that is. 3.14 minus 0.97. That is 2.17. 2.17. And then the first one we got, that is just straight up one of our answers. 0.97. And that one's done. Right? So now on the next one, thing to remember is that's negative. All right, so where is cosine negative? If we just do another one of these things, all students take calculus. We know cosine is negative in quadrants 2 and quadrant 3. All right, so our 2 angle measures should be, somewhere over there. So we just have to be careful when we're typing this in. What is that value that we're looking at? Is that a reference angle or is that one of our answers? So let's just, carefully plug it in and see what happens. So we have the cosine, the inverse cosine of negative 0.45755. That's going to give us 2.04. Right? So over here, where is 2.04? That is somewhere in quadrant 2. This is 2.04. That is not a reference angle, right? That is something we need to keep in mind. This value right here is our reference angle. So to figure that out, you're just going to have to do 3.14 minus 2.04, right? So the reference angle here is 1.10. Right? So this angle right here, I forgot what it was, 2.05. If we round 2.05. So that means this reference angle right here is just 3.14 minus 2.05, which gives us 1.09. So we have a reference angle of 1.09 radians. So to figure out the red angle there, right, to figure out this whole thing, we're going to have to do pi, or actually I'm using 3.14. We're going to use 3.14 plus that 1.09, because we have to go 1.09 past pi radians. Right? So plus 1.09 right? And that's going to give us that second angle, which is going to be 4.23. And that is radians. So the first answer, theta, was equal to 2.05 radians. And then the second answer, theta, is equal to 4.23 radians. All right. Now we have one more. It's the cotangent. And remember, cotangent matches up with the tangent. So we're going to say the inverse tangent of 1 over, because it is that reciprocal, you get 1.2255. Punch all of that in. Let's see what we get. So the inverse tangent, 1 over 1.2255. 0.684. 0.68. So cotangent matches up with tangent. It's a positive number. So all of our students will take calculus. That means it needs to be in quadrant 1 and quadrant 3. All right. So this first one here, that's 0.68. And then the next one needs to be down here. That same reference angle of 0.68. Now we just have to figure out what that angle is. All right, so the first one, that's just, the answer straight up. Theta equals 0.68 radians. The second one is 3.14 plus 0.68. All right, that's our second value, our second, angle, which equals 3.82. Right. And if we type that in, and so we're looking at the cotangent, so I'm going to say 1 over the tangent. We just type in 3.82. Punch all that in, press enter. That's going to give us that value there. And it's a little bit off because we did round, right? But it's pretty close, right? We have 0.22 is 0.24. All right. When we round to 2 decimals, we are cutting off a lot of that value there. So it's just one thing to keep in mind when we round. Our answers will vary just a little bit here. All right. But after, 30 attempts, page 3 or page 4, whatever we're on, is done. All right. So I'll see you in the last page.